We're asked to approximate the x value where the maximum value of y equals sine x minus 2x squared occurs using Newton's method. We're told to round to 4 decimal places. Newton's method uses tangent lines to approximate the zeros of functions, and the formula for Newton's method is shown here. But this problem is a little bit different. Notice here we're looking for the location of the maximum value of the given function, not where it's equal to 0. But remember, the maximum value must occur at a critical number, and a critical number is where the derivative of y is equal to 0 or undefined. So what we'll do is use Newton's method to determine where the derivative of y is equal to 0, which will give us the location where y has a maximum value. So for Newton's method, f of x is going to be y prime, and then f prime of x will be the derivative of y prime, or the derivative of f of x. So again, we'll let f of x be equal to y prime, which will allow us to approximate the critical number where y has a maximum. So if y is equal to sine x minus 2x squared, then y prime, or f of x, is equal to cosine x minus 4x. And f prime of x is equal to negative sine x minus 4. To get a better understanding of our approach here, let's look at the graph below. In purple, we have the graph of the original function, y equals sine x minus 2x squared, and we're looking for the location of the maximum of y, which occurs at this high point here. The location must occur where y has a critical number, which again is where the derivative function, in this case, is equal to 0. So I've also graphed y prime, which we're using as f of x for Newton's method here in red, and notice how the 0 or x-intercept of the derivative function, or f of x, does give us the location where y has a maximum. So we're actually using the derivative function, or the red function, as our function f of x in Newton's method to determine where the original function y has a maximum. The initial approximation can be labeled x sub 0 or x sub 1. Let's go ahead and call it x sub 0. Using the help of the graph, we're looking for a point that's close to where f of x, or y prime, has a 0 or x-intercept, and let's go ahead and use 0.2. Notice 0.2 is close to where y prime, or f of x, has a 0, which again is close to where y has a maximum value. And then as we run Newton's method, we will get closer and closer to where the derivative function is actually equal to 0, which again will also get closer and closer to where y has a maximum. And now we're going to use Desmos.com to create a table similar to the one below to make our approximations. And because we're told to find the answer to 4 decimal places, we will keep running iterations until the approximations are the same, rounded to 4 decimal places. So let's go to Desmos.com. First, let's make the calculation screen larger by moving the cursor to the edge of the calculation window until we see a double arrow. Then we click, hold, and drag it to the right. First, we'll enter the function we're using for Newton's method, which is really y prime, which we already know is f of x equals cosine x minus 4x. Now, when using Desmos, we don't actually have to find the derivative function, because Desmos will determine derivative function values as long as you use the prime notation. So now let's go to cell 2, click on the Add Item button above, and then select Table. And now we are going to recreate the table we had on the previous slide. Let's clear x1 and enter n. And we'll clear y1 and enter x, tab. Then we have f of x, tab, f prime of x, tab, and then the formula for Newton's method without the n subscript is x minus f of x divided by f prime of x. And now let's go back to the n column. Let's enter n equals 0, enter 1, enter 2, enter 3, enter 4, enter. We'll go back up to the row where n is 0, enter our first approximation, which we selected as 0.2, and notice how the entire row populates. The last entry in this row is x sub 1. Notice the 4 decimal places, x sub 1 is 0.2429, which will enter in the row where n is 1. So again, x sub 1 is 0.2429, And again, we're going to keep running this until our approximations are the same to 4 decimal places. Again, notice how the row populates automatically. The last entry is x sub 2, which to 4 decimal places is 0.2427, which we enter in the row where n is equal to 2. And again, the row populates, and the last entry is x sub 3, which notice is also 0.2427, and therefore we can go ahead and stop. The location where the original function y has a maximum is approximately 0.2427. Let's go back and record this. So again, the location where the maximum value of y equals sine x minus 2x squared occurs using Newton's method is x is approximately 0.2427. And before we go, let's verify this graphically. This graph shows the original function graphed in purple as well as the derivative function graphed in red, and we used y prime as f of x for Newton's method. Notice how the 0 of the derivative function, which is the critical number, is shown here as 0.2427, which is the same location as the maximum of the original function y equals sine x minus 2x squared. And we can also see from the y coordinate that the maximum function value is approximately 0.1225. I hope you found this helpful.